We want to graph the sine function. So what we're going to do first is we're going to write the values of the sine for one period, because we said after that it repeats itself. And 0 and 2 pi are the same, so we're going to go from 0 all the way to 11 pi over 6 for the values on our unit circle. So at 0, the sine is 0. At pi over 6, it's 1/2. Pi over 4, it's radical 2 over 2. Pi over 3, it's radical 3 over 2. Pi over 2, it is 1. 2 pi over 3 is radical 3 over 2. 3 pi over 4 is radical 2 over 2. 5 pi over 6 is 1/2. You can keep on going. Here it's 0 again. Here it's -1. Here, the rest of these, it's negative. So at 7 pi over 6, it's 1/2, as well as 11 pi over 6. And at 5 pi over 4, it's radical 2 over 2. And here it is radical 3 over 2. Those are a lot of points. I could graph them. I have 0. I have pi over 2, it's here. Look what happens, and I could have graphed these other points. I have pi over 4, it's about here. Pi over 3, it's at 1/2, and it goes up here. But see, if I just graph those points, here, 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 and here, and then again at 2 pi, where it is 0, we call these the key points. And look how nice we can just graph get a pretty good idea of what the graph looks like just using those key points. Well, let's talk about the properties. We talked about this before. The domain of the sine is negative infinity to infinity. The range is -1 to 1. It is odd. If we go back and look at the function, we can see if I graphed more over here, it would look like this, and that makes it an odd function, symmetric with respect to the origin. Its period is 2 pi. It has x-intercepts at pi, 2 pi, right? Where n is an integer. It crosses the x-axis everywhere there, and its y-intercept 0 here too. Y-intercept is at 0. So we can graph the basic sine function here, and what we're going to learn next is how to graph when we do transformations.